So this video we're going to look at using an anonymous function to solve a particular equation, and the equation that we're going to solve is this one here, cos of x is equal to x. So the first thing that we should do is produce a plot of these things just so we can get a bit of a feel for what these functions look like. So for example, we're going to find out whether we're looking for one solution or two solutions or whatever. So let's actually write some code quickly to plot that. So let's say we wanted to plot it over the range -5 to 5. Maybe I'll take 200 points, and I want to plot cos of x and just x by itself. So if I run that, this is what it looks like, and so we can see that there's going to be one solution. Okay, this is it here, and it's going to happen at about 0.7, something like that. Yeah, 0.72 or so. So that's approximately the solution, or the place where we should be looking for the solution. Okay. So the function that we're going to consider is this one here called f0. And so what this does is finds the root of a continuous function in one variable. And so the way that we're going to use that function is by doing this. So if we have cos of x is equal to x, then we can rearrange that equation into cos of x minus x is equal to 0. So that some function f of x is equal to 0. And so this f0 function here will find the x value for which a particular function is 0. And so if the function is this one here, then we solve this equation. So f0, let's look at that syntax again. It needs the function handle to evaluate and also an initial starting point or a guess. So let's go ahead and write that. We can use an anonymous function here to represent the mathematical expression that we want. So we want cos of x minus x, and so this block of code here produces an anonymous function that implements cos of x minus x. So that can be our function, and we said that the answer was close to 0.7, so let's use that as our initial starting guess. Now we should display this result so that we can see what it was. So let's run that, and we find that the exact answer is 0.739. Suppose now we want to modify this routine so that it becomes cos of a times x, which is equal to x. Then it's pretty easy to see that that will modify our function so that it's cos of a times x subtract x is the thing that we're trying to reach 0. So I put a times x down here. Now that won't work, of course, because we don't know what a is, so I can supply a value. Let's say that a is equal to 3, for example, then we can put that in here. So this seems kind of obvious, but there's actually something a little bit subtle that's going on here, which is that this value of a is not defined anywhere inside this function. Right? Remember that the anonymous function is this little set of characters here, and that's it. But it's able to access this variable a because this anonymous function takes on the scope and takes on the workspace of the place where it was created. So this variable a is accessible to this line of code, this whole line of code here, and so therefore this anonymous function has access to that variable as well. So if I run that, our answer is now 0.39 instead. And so I can put in different values here for a and get out different solutions each time.